Hello everyone, welcome to my channel Yashita Decodes. So in this video, we'll be learning about chapter 6 of class 12th computer science, which is exception handling. So we'll be covering the following topics: introduction, exceptions and exception handling, concept of exception handling in Python, general built-in Python exceptions, second argument of the except block, handling multiple errors, the finally block, and raising and forcing an exception. Okay, let's get started. Introduction. Errors may occur while executing a program. So whenever a program is run in a computer, there are chances that it might encounter errors, right? Because a program while running will be interacting with multiple databases, opening and closing files, performing great computations. So there are chances that something might go wrong in between. So errors may occur. Such errors can cause abnormal termination of the program, right? So let's say user was trying to open a file which isn't present at the location which is given by the user. So it will give us an error that file is not present. Or if we are performing a computation and the value is way too big, so then overflow error could occur. So there are multiple instances that errors could come and they can cause abnormal termination of the program. Exception handling is a way to manage these errors gracefully. So here in this chapter we'll be learning about exception handling. And what is exception handling? It provides a way to manage these errors gracefully. It prevents program crashes and improves reliability. So when we do exception handling, when we perform exception handling in our code, then what happens is a program is not crashed in between. And that is what we want. We do not want a program to terminate abnormally in case if any error is encountered. Exceptions and exception handling. So what is an error? An error is a problem in a program that causes the program to stop or produce incorrect results, right? Something that is interrupting with the flow of the program, or something that is causing the program to produce incorrect result. That is an error. An error prevents the normal execution of a program. Errors in Python are broadly classified in two types: compile time errors, that which are syntax errors, runtime errors, which are exceptions. Okay, so we'll be learning about both of these. Okay, so what are compile time errors or syntax errors? These errors occur when Python interpreter finds a violation of Python syntax rules before executing the program. So we know that while writing Python, we have to follow certain syntax rules. In case if there is something wrong with the syntax, for example, if the colon is missing, or if the brackets or quotes are missing, or if the indentation is not correct, then it causes compile time error. That is why it is very important to write the programming language in its correct syntax. Otherwise, compile time errors are generated. Next is runtime errors exceptions. Now these are exceptions. Now what are exceptions? So these errors occur while the program is executing, even though the program is syntactically correct. So here in this case, the syntax is correct. Nothing is wrong in the syntax. But while performing the computation, something has gone wrong. Something wasn't right. So that causes runtime errors. Such errors are called exceptions. When the syntax is correct, but while performing some computation, let's say it was performing a division, but the division wasn't correct. So at that time, runtime error could occur. So what are the examples? Like division by 0. If division by 0 is performed, then it would generate runtime error or exception. If we try to open a non-existent file, the file which is not present at the certain location or not present at all, if invalid type conversion is performed, then that would generate an exception. So what are exceptions? An exception is an abnormal event or error that occurs during the execution of a program and disrupts the normal flow of instructions. So a program follows set of instructions. according to what code we have written, it would follow instructions, it would follow that code. But if something goes wrong while following those instructions, while executing the code, if something goes wrong, then an exception occurs. So an exception is an abnormal event or error that is occurring while we are executing our program. Some common built-in exceptions are zero division error, value error. Now to handle these exceptions, we do exception handling. So exception handling is a mechanism that enables a program to detect, handle and recover from runtime errors without terminating abruptly. So we do not want a program to terminate abruptly. So in order to prevent that abnormal termination of a program and for us to detect, handle and recover from those errors, we do exception handling. Python provides try except construct for exception handling. So in Python we say try, and inside the try block we have statements that may generate an exception. So all the computation where errors could happen, where errors could occur, they are kept inside try block. And inside this except exception type, so exception type is the kind of exception that could occur. So we mentioned the exception type, and here except exception type block, inside that we'll be writing statement to handle the exception. So I'll just show this on PyCharm. Okay, so let us write a program to input two numbers and display their division. If any error occurs, display an error occurred. So first we will put this code inside try block. Let us say a is equals to int input, enter first number, b is equals to int input, enter second number, then we'll be printing result a divided by b. And inside this except block we say print an error occurred. So I'll just right click and run it. Okay, so it is asking me to enter first number, let me enter 10, then second number, let me enter 5, and here the result is 2.0. Here in this case no error occurred. Here the user entered the first number, then the second number, and we printed the result by dividing first number by second number, and no error has occurred. So this except block is not executed. Now let me rerun it. I'll just enter first number 10, let us enter second number 0. So here it says an error occurred. So in this case, because we performed zero division, so it has given me an error occurred. This example demonstrates exception handling without using any specific built-in exception names. We have just printed this generic an error occurred message. So here it will catch all kind of exceptions. See, in case if I rerun it and I say enter number a, so it has given me an error occurred. Since this number a cannot be converted to integer, so it has given me this error because this is a value error. So this except block will catch all kinds of errors. So it is useful when the programmer wants to display a generic error message and it does not tell the user which specific exception has occurred. But in case of professional programming, it is recommended to catch specific exceptions. So we should know exactly what has gone wrong, what error has occurred. So in case if division by 0 is attempted, it should give me zero division error. If the value is not correct, it should give me value error, because then debugging becomes easier. So I'll just comment this out, and here side except, if I say except zero division error and print division by 0 is attempted, and here we'll say value error, print please enter valid value. So in this case, if I right click here and run it, let me just enter first number 10, second number 0. So it has given me 0 division by 0 is attempted error. So here I know exactly what has gone wrong. What did I do wrong? Now I'll just rerun it. Let me just enter, let's say, value 20 and B. So it says, please enter valid value. This time it has not given me this message, division by 0 is attempted, because in this case value error was there. So if an exception occurs, Python transfers the control to the appropriate except block, preventing abnormal termination of the program. So this is the general idea of exception handling. This is how exception handling is performed. And now we'll be learning more exactly how it is done. So what are the advantages of exception handling? Why do we do exception handling at the first place? So it prevents abrupt termination of programs due to runtime errors. So whenever any runtime error is encountered, program will not get terminated abruptly. Rather, it will show us the message, exactly what has gone wrong. Separates error handling code from normal program code, making programs easier to understand. So all the error handling code can be kept inside try block, and corresponding exceptions should be given, and normal code can be kept outside the try block, because the user knows exactly what all code is there where there are possibility of errors. So that code can be kept inside try block, and it separates error handling code from the normal code. So programming becomes easier to understand. It improves program reliability and robustness, allows graceful recovery from errors and continuation of program execution. The program is not terminated abruptly, and it allows graceful recovery from errors, and we know exactly what has gone wrong because it provides meaningful error messages to the user. Simplifies debugging and maintenance of program. So when the user know exactly what has gone wrong, so debugging becomes easier, maintenance of program becomes easier. So this exception handling helps in developing user-friendly and fault-tolerant applications. Okay, next is concept of exception handling. Many programs interact with users, files, database, or networks. During execution, unexpected situations may arise. What are these unexpected situations? Like if user entered invalid data, or division by 0 was attempted, the required file from where we want to access the data is missing, invalid list index is accessed. In all these conditions and many more such conditions, such unexpected situations would lead to generation of exceptions, right? So the normal flow of program will be interrupted because of these situations. So these situations cannot always be predicted while writing the program. So even if we try to be very mindful while writing the program and think what are the possible edge cases and what all things can go wrong in between, even then there's this possibility that we could miss something, right? Therefore, exception handling is required to make programs more reliable and user-friendly. So the next topic is exception handling in Python. So Python provides try and except block to handle exceptions. So we also saw that on PyCharm, that there's a try block and there's this except block, and using try and except block we do perform exception handling in Python. The code inside the try block executes. Python first execute all the statements inside the try block. So whatever is written inside the try block, we first try to execute that. If no exception occurs, program skips the except block. If nothing has gone wrong, then we don't need to go inside except block, okay, and we continue with the remaining statement. Now, what if an exception occurs? So if an exception has occurred, so if any statement inside the try block causes an exception, so what will Python do? It will stop executing the remaining statements in the try block. It searches for the matching except block. So according to what exactly has gone wrong, it would search for the matching except block. If division by 0 was attempted, so it would look for 0 division error. If invalid value was given, it would look for value error. So it searches for matching except block. It executes the statement in that except block, and it continues with the rest of the program. In this example here, we are saying a is equals to 10, b is equals to 0, and we're printing a by b, and then we are printing this statement is skipped. This is the code inside try block, and we will try to execute all these commands inside try block. If everything goes right, we do not have to execute except block. But here, when we try to perform this division a by b, so here we are dividing 10 by 0. So this division is not possible. So when the control will come here and it will try to perform this division, at that time it will encounter an error. So the control would shift from here to this except block, and it will go here and it will print division by 0 is not allowed, and then it will print next program continues. So this a by b division is not executed. So this is how exactly the flow works. The next topic is common built-in Python exceptions. So we have been talking about these exceptions like zero division error, value error. So what are these exceptions? So they're already written inside Python language, and while performing exception handling, we just have to use them. So like we have already seen zero division error. So it is raised when number is divided by 0. Value error, when a function receives an argument of the correct type but an invalid value. Example, int abc. So this abc cannot be converted into integer. So here this will raise value error. Type error, raised when operation or function is applied to an object of inappropriate type. Example, adding a string and an integer. So let's say if I try to add 20 with 5. So since this is of type string and this is of type int, so they cannot be added together. So this will raise type error. Name error, raised when a variable or function name is used before it is defined. So we know that we always have to define a variable or a function before calling it, before using it. So in case if we haven't defined it, then it would generate name error. Then index error. So raised when invalid index is used to access a list, tuple or a string. So let's say if our list has 3 values and we try to access index 4, so it would raise index error. Then we have key error. It is raised when a dictionary key that does not exist is accessed. So let's say in our database we are performing some computation on a table and a column from that table is deleted, let's say. So, and if we try to use that particular key, use that particular column, it would raise key error. The next is file not found error. It is raised when attempting to open a file that does not exist. So if you're trying to open a file which is not there or which is not present at the location which is given, so it will say file not found error. Then import error, raised when Python cannot import a module or a member from a module. So if it fails to import it, then it will give import error. Then attribute error, raised when object does not have the requested attribute or method. Then module not found error, raised when the specified module cannot be found. UFF error, it is end of file error. It is raised when input function reaches the end of the input without reading any data. So all the data has been read and it has reached at the end and no more data is there. So it will give us end of file error. Then we have overflow error, raised when the result of calculation is too large to be represented. So it is common with like floating point number operations or when we use math module. In those scenarios, overflow error is encountered. Memory error, raised when an operation runs out of available memory. Recursion error, raised when the maximum recursion depth is exceeded. Keyboard interrupt, raised when the user interrupts the execution of a program by Control C. Then assertion error, raised when an assert statement fails. So these are all the built-in exceptions which are already there and we can use them while performing exception handling. Okay, so the next topic is second argument of the except block. So in Python, second argument of the except block refers to the exception object or exception variable. It stored details about the exception that occurred and it's written using as keyword. See, here inside the try block, we are writing the normal code where exception can occur, and here inside this except block, here we say accept exception type as variable name. So this variable name, this is the second argument, and it is written using this as keyword. So this is what it is written here. It stores details about the exception, what exception has occurred. So the details about that exception is there, and it is written using as keyword. So exception type is the type of exception, like zero division error, value error, and variable name such as like it could be E or a message, whatever, is the exception object which contains information about the error. It has the information about the error. Okay, I'll just show this on PyCharm so that it becomes clear. Okay, let us say inside the try block I have this number 10, A equals to 10, B equals to 0. Then here I print A divided by B, and in here we have written except zero division error as E. This is the variable name, E is the variable name, and then I print exception E. So when I right click here and run it, it has given me division by 0. So this division by 0, this is the information about the error. So because we printed E, so the value of E is division by 0, because in this case zero division error is there. So see, zero division error is the exception type, E is the exception object, and printing E displays the error message generated by Python. So this is what is the second argument. Okay, let me just show you one more example. Say inside try block we have number is equals to int ABC, and here I say except value error as E, and I print error E. So when I right click it, so it has given me invalid literal for int with base 10 ABC. So this information that this is the invalid literal for int with base 10 ABC, so this is printed because here we are printing E. So this is the use of second argument of except block. So we use this exception object because it displays the actual error message, right? We understand what went wrong. It provides more informative message to the user, and it debug programs more effectively. So that is why we use this exception object. Okay, let me just show you one more thing. See, here we have used the second argument. What if we do not use the second argument? And if I print except zero division error, print cannot divide by 0. So in this case, if I right click here and run it, so it has just printed cannot divide by 0. But when we were using this exception, it was giving me error division by 0. So that time it was printing the error message generated by Python, and we were able to get that message because we were using the second argument. Okay, so the next topic is handling multiple exceptions. So here sometimes a single try block may generate different types of exceptions. Okay, so different types of exceptions can be generated when we try to execute the code inside the try block. In such cases, Python allows us to handle each exception separately by using multiple except blocks. This is known as handling multiple exceptions. See, here we have this try block. Inside this try block, we'll write the code where exceptions could be generated. Then we have this except block, exception type 1, exception type 2, exception type 3. So in this way, we can write multiple exceptions here. What happens is Python checks each except block in order. When a matching exception block is found, its corresponding except block is executed and the remaining except blocks are skipped. So what happens is, first it will try to execute all the statement inside the try block. Okay, so whatever is written inside the try block, it will try to execute that. So if no exception is encountered, if the code inside the try block was run smoothly, then we'll just skip the exceptions. But what if an error was occurred? So it will try to search for the matching except block. So it will search for the matching except block. Now, and the matching except block is executed, and the remaining except blocks are ignored. And if no matching except block is found, then the program is terminated. So this is how it works. Fine. So I'll just show you on PyCharm exactly how this is working. Okay, so here we have already seen this example. Here what we are doing is we are entering the first number, we are entering the second number, then we are dividing that number A by B, and here we have given two exceptions. So based on what error has encountered, it will execute that particular exception. So in case zero division was attempted, so it will come here and it will execute this code. It will say except zero division error, so it will print division by zero is not allowed, and if value error is encountered, then it will print this particular code. See, I'll just right click here, and if I say first number A, so it gives me incorrect value. Okay, so here it has said enter first number. So when I entered first number, I entered A. Okay, so because A cannot be converted into an integer, so it has given me incorrect value. So because here value error was encountered, so it gave me incorrect value. If let's say I'll just rerun it, I'll just enter 10, then 0. So it gives me division by 0 is not allowed, because here in this case zero division error was encountered. So in this manner we can give multiple exceptions, and based on what error is encountered, it will execute that particular exception block. Okay, let me just show you one more example. We say handling index error and type error. Inside the try block we have L is equals to, this is a list, we have sent 20, 30. Then we have this index, and we'll take input from the user. We'll say int input, enter index. Then I'll say print L index. We're printing this particular index. Here we'll say except block, except value error, and I'll say print please enter a valid integer index. Then I say except index error, print index is out of range. So I'll just right click here and run it. See, it has asked me to enter index. Let me enter index 1. So here it has given me value 20, because at 0th index 10 is there, at first index 20 is there, second index 30 is there. So it has given me value 20. Now let me just input value. Let me input value 3. So it has given me index out of range, because like we have three values, 0 at index 0, at index 1, at index 2, and index 3 there is no value. So index is out of range is given. Now let me run it again, and I say B. So it gives me, and please enter a valid integer index, because here it has given me value error. So in this manner multiple exceptions are handled. So one question could arise in our mind, that how does Python know which exception has occurred? So we have given multiple exceptions for performing exception handling, and how does Python know exactly which exception block should be executed? So when Python executes a statement, it continuously checks for errors. Every operation in Python has built-in checks. When the Python code is written, inside that code we have checks. It keeps checking for errors. If an operation fails, Python creates an exception object of the appropriate type. When we say 10 divided by 0, Python detects division by 0 and creates a zero division error object. And when we say int abc, Python detects that the string cannot be converted to an integer, and it creates value error object. Okay, let me just explain this with the help of example. So what is happening here is, see, inside this try block we have this code. So Python executes num integer int enter first number. Here built-in function validation is performed. So built-in function performs validation. So what is int function is written by developers. Internally it checks if the given string a valid integer or not. So what is happening is, here we say int enter first number. So this internally built-in function will perform validation. It will check if the given string is valid integer or not. Okay, so let's say if 5 is given or 25 is given, then yes, it is a valid integer. If ABC or XYZ is given, then it is not a valid integer. So it will raise value error and it will come here. And if this second number is 0, okay, so when performing division, again it will raise zero division error. And since zero division error is raised, so it will come to this block and this code is executed. So internally what is happening is, internally Python is written in C language. So C Python is executed. So how it is working is, Python stops the try block as soon as the exception occurs. Then Python stores the exception. Internally Python keeps information like, it will be like exception type, value error, exception, object, invalid, literal for int. Okay, so in this manner internally the information is stored. The Python, and then the Python searches for the except block which matches this exception type. Python compares the exception type with each block from top to bottom. So whenever that exception type matches, that particular exception block will be executed and the rest exception block will be skipped. So I hope this thing is clear, how exactly Python is able to identify which exception block to run. See, internally Python is written in C Python. Built-in functions and operators are implemented in C code. When an error condition is detected, they create an exception object such as value error or type error, whatever error, and signal it to the Python interpreter. And then the interpreter unwinds the current execution until it finds a matching except block. If none is found, it prints a traceback and terminates the program. So I hope this much is clear. So this is the idea behind giving multiple exceptions. Whenever an error is executed, it will match for that particular exception. That exception block is run. All the other exception blocks are skipped. If no exception block matches, the program gets terminated. Okay. Okay, so the next topic is the finally block. So the finally block is an optional block used with the try except statement. It contains statements that always execute, whether an exception occurs or not. All those statements that we want to be executed, irrespective of whether the code was run smoothly or whether an error was occurred, are put inside finally block. So why do we need this finally block? The finally block is generally used to perform cleanup operations, such as closing files. So if we have written a code where we accessed few files and we opened them, irrespective of what error occurred in between, we are supposed to close that files. So we'll put them inside finally block. Releasing system resources, closing database connections. If we have established a connection with a database, then it is important we close that connection for security purpose, so that security breach does not happen, our database is not compromised. So with that, put that inside finally block. Then displaying a final message. Since the finally block always executes, it ensures that important cleanup tasks are completed regardless of whether the program executed successfully or encountered an exception. Okay, so this is the syntax. Here inside the try block, we'll write all the code where an exception could be generated. Inside we mention all those exception types, statements that handle the exception. And then inside finally block, we write the statements that we want to be executed irrespective of whether our program ran smoothly or if whether an error was encountered. So let me just show you a few examples on PyCharm. Okay, let us see this example of closing a file. So inside the try block, let's say I have opened this file which is student.txt and I've opened it in read mode. Then I say print f dot read. Then we say except file not found error, and I print file not found, and inside finally I say print closing a file. Inside this we'll write try. We say try f dot close, and here we say except pass. Okay, so what we are doing here is we are opening this student.txt file in read mode, so this file should be present there. Then we are trying to read this file. If the file is not found, it will give us this error, file not found error. And then inside this finally block, we are printing closing a file. So if the file was found and the file was opened, it will come here inside this try block. It will execute this code f.close. If that file was not opened, it will just pass. But here we are putting this code f.close inside finally because we want this file to be closed if it has been opened. Okay, so I'll just run it. It says file not found and closing a file. So it has run this because we couldn't find this file, and then it will print closing a file. It will try to close this file. Since file was not found, so it will come here and it says pass. So here the idea to keep this code f.close inside finally block is so that our file, this f.close, is performed irrespective of whatever error or whatever exception was generated in between while running the file. Okay, so let us see another example. So this code is already written. Here we can write this finally block as well. Let me say finally, and inside this we print program ended. So irrespective of whatever error has occurred, let me just run it. So I say enter first number 10, enter second number 0. So it says division by 0 is not allowed, and then it prints program ended. So this message is printed because it has been put inside finally block. Okay, let us just summarize whatever we have read till now. Here it says try block contains risky code. So it contains statements that may generate an exception. So all the code where there are chances that errors might occur, all that code is put inside try block. Then we say except block handles the exception. Inside the except block, we give the exception type and the statement that we want to be executed. The except block handles that exception. If the specified exception occurs, the corresponding except block executes. Next, multiple except blocks are allowed. So we have read this, that a program may produce different kinds of exceptions. Python allows multiple except blocks to handle each exception separately. So there are multiple exceptions can be written, and according to what error has occurred, it would match the exception type and execute that particular except block. Only the matching except block executes. Correct. Then if no exception occurs, the except block is ignored completely. So if everything goes right while running the program, then there is no need to get inside any except block. So the except blocks are ignored completely. If no matching except block is found, so what if there is an exception but we aren't able to find any particular matching block to it, right? Like all the exception types, they do not match the exception which has occurred. So what will happen is the program will get terminated. Okay, so Python terminates the program and displays the default error message. See here what is happening is it is trying to add 10 plus this string. This is string, right? It is inside double quote, so it is a string. So here the output is type error unsupported operand type. Okay, this is the output which will be displayed on the screen, and since type error is not handled, we can see here we have given except value error, but type error is not handled here, so the program terminates and this is printed. So now the next topic is raising and forcing an exception. Sometimes a program needs to generate an exception explicitly when a certain condition is met. This process is called raising or forcing an exception. So if in between our program we want it to raise an exception, let's say I am asking user to input a number, and if I want an exception to be raised at that time if the number entered by the user is negative. So in that scenario we can raise an exception. Python provides a raise statement to manually generate an exception. Okay, so there's this raise statement to manually generate an exception. Instead of waiting for Python to detect an error automatically, the programmer can use raise to stop the normal execution of the program and indicate an exception situation has occurred. But why do we need to raise an exception when already we are doing exception handling? Then why do we need to manually add raise command and add an exception? Then why do we need that? So the raise statement is used when invalid data is entered by the user. As I said, like we wanted user to enter positive value, but user has entered negative value. We don't want that. We don't want our program to continue with the negative value. So we'll just raise an exception at that point. A business rule or condition is violated. The programmer wants to prevent further execution of the program. Let's say if the negative value is entered, it would further process using that negative value. And we don't want that to happen because we don't want that computation which wouldn't lead to any desired result. So we want to raise an error then and there. Okay. A custom error message needs to be displayed. So what is the syntax? Raise exception type or raise exception type error message. So this is how we raise it. So here raise is the keyword used to generate an exception, and exception type is the type of exception to be raised, and error message is optional and provides additional information about the exception. So I'll just show this on PyCharm so that it becomes clear. So let's say we want to write a program that accepts a positive number if user enters a negative number, raise a value error. Okay, so let us just first ask user to input the number, the int input enter positive number. Now if number is less than 0, raise value error, and we say negative numbers are not allowed. Okay, if number is negative, then we are raising this value error. Then we say print you entered, and you will say number. Then inside except block, please generate value error as E, and here I print this error. So what we are doing is we have asked user to input the number. So if the number is less than 0, here this is the condition, if the number is less than 0, in that scenario raise value error, negative numbers are not allowed, then print the number that you have entered, and then we have this except block here. In case any other number is entered that is not desirable, it will come inside except block. Like let's say if user has entered any string, then this will be executed. So I'll just right click and show you. So it says enter positive number. So let's just enter 10. So it gives me you entered 10. Now let me enter -5. So here it has given me error, negative numbers are not allowed. So here because we have raised this exception, so it has given me negative numbers are not allowed. Now let me run it again in case I enter n. So here in this case, because if it has entered n, so it will come inside this block value error as E, and it will print E. What is the error? What is E? It is the message invalid literal for int base 10n. So this is how it is working. In case of negative number, we have raised this exception because we don't want user to enter any negative number. If this was not there, see, if I'll just comment this out and rerun it, and here if I say -7, so it says you entered -7. Okay, so that is why we have used raise, because we don't want any negative number. So this raise statement is used to manually generate or force an exception. See, we are forcing an exception when a specific condition occurs in a program. It enables users to enforce rules, validate input, and prevent invalid operations. This raised exception can either terminate the program or be used handled using a try except block. Like in this case, we are using inside try except block, making programs more reliable and easier to debug. I hope this much is clear. So the last topic of this chapter is benefits of exception handling. So in this chapter, we have already seen what is exception handling, why do we do exception handling, how do we do exception handling. So what are the benefits? So I think this is now kind of clear already. Why do we do exception handling? It prevents abnormal program termination. The exception handling prevents the program from terminating abruptly. The program will not end suddenly whenever a runtime error occurs, right? Instead, the program handles the error gracefully and continue execution. Then it improves program reliability. The program becomes more reliable because unexpected errors are detected and handled properly, right? Reducing the chances of program failure. So it becomes more reliable. Then it separates error handling code from normal code. Exception handling separates the code for handling errors from the main program logic. See, all the code where the exceptions can happen, they are written inside try block, and then in the separate except block, we mention all the exceptions. So we are separating error handling code from normal code. It helps in making the program easier to read, understand, and maintain. Then it provides meaningful error messages. So instead of displaying complex Python error messages, programmers can display simple and meaningful messages that are easier to understand to user. So that also is possible. We can give our own messages, or we can use messages given by Python by using second argument, right? Then it handles different types of errors. Python allows different exceptions to be handled separately using multiple except blocks. This enables program to respond appropriately to different error conditions. So that is why we have read why do we have multiple exceptions. Makes program user friendly. The user receives clear instructions and messages when an error occurs. So it helps in making debugging easier. So see, the next point is simplifies debugging and maintenance. Why? Because user know exactly what has gone wrong and user can read the particular message. So debugging and maintenance becomes easier. Then it ensures proper resource management. By using the finally block, resources such as files, database connections, and network connections can be closed properly even if exception occurs. So we have seen the finally block. So using that, if the connections are closed, so proper resource management is ensured. Okay, so this concludes chapter 6, exception handling. So I hope all the topics explained are clear. If you find any topic hard, or if there's any confusion in any topic, then please mention in the comments. And if this video was helpful, then please hit the like button and do subscribe if you are liking the video so far. Okay, thank you. Happy learning.